Imagine a human tribe living in the island of Zanzibar, and they look across the water and they see this huge mass of land, which is Africa, and assume that they were the only humans on Earth. And then some of them think, if we kind of build something to cross this water and go and live in that large land that we see, what would it be like? And the answers, of course, if they were to cross the water, they could colonize the whole planet Earth. And now we are in a similar situation with the colonization of space. Moving from Zanzibar to Africa, increase the carrying capacity by maybe, let's say, 1,000 times, 10,000 times, maybe even 1,000,000 times. I don't know. I mean, you can do the math. But the point being that if we were to colonize space, the expansion in carrying capacity would be far larger than moving from Zanzibar to Africa. But then, of course, the question is that true? And if to answer the question, we need to, do some proper engineering calculations about what exactly is the opportunity that exists if humans were to colonize space. Yeah. So in the chapter of my book, there is this section in which I talk about colonizing our solar system. And later I talk about colonizing our galaxy, and then whether it's possible to colonize other galaxies. And these are not wishful thinking. These are actual numbers which have been the math and the engineering issues are worked out. And the results that are there should be like accurate within maybe a third of an order of magnitude. An order of magnitude is a factor of 10. So I would say that within a third, this way or that way, these numbers should be accurate. So we are going to look at building of space habitations. And these space habitations, when you think of habitations in space, there are some there are four major issues that you should consider first. Okay, now the first is gravity. What we know is that human bodies don't develop properly in the absence of Earth-like gravity. There are problems with the immune system and stuff like that. So we need the proper amount of gravity. Then we need agriculture, because if we are going to really say that we are going to go and live in space, then obviously if we are to have to send food from Earth to space, that's not really an expansion of humanity. A true expansion of humanity would be when space is actually able to provide everything that we need for life. So that means that we have to develop agriculture. Now, space, as we now know, there is a challenge of radiation, and we need protection from radiation. And finally, the claim is that there are a lot of resources in space. If that is the claim, that we should really go to space because there's so much more resources, physical resources in space, then space should be able to provide us luxurious living. And really, I mean, if you're going to make all that effort of getting to space, you don't want to live in like you want to have a great life. Okay, so it has to have luxurious accommodation. So these are the 4 requirements for colonizing space. And to fulfill these requirements, I have in this book chapter the design of a space habitation, and you can see that this space habitation that the cross-sectional view of it, it shows that it has agriculture zones, it has lakes, it has parks, condos, offices, malls, factories, stadiums, hiking trails, bike paths. So this is what we as modern humans consider to be the necessities for a good life. It has everything. So this space habitation, this design, which I go into detail in the book, has all these, meets all these requirements. And there is one very important number which comes out of the design of this space habitation. And that number, what is that number? That number is the amount of mass needed per capita to build these habitations. If the amount of resources in space was enough for, let's say, 1 million humans, we are already about 8 billion on Earth. And then you make that effort and you say, oh yeah, we can go to space and we can have a really great life there. And so the question is, for how many people? And the answer depends upon how much mass is needed and how much mass is available in space. Okay. So that is a very important number. And throughout this book, that number will appear again and again and again. And that number for this space habitation is 1.42 trillion kilograms for a space habitation which houses 50,000 humans in luxury, living lives of luxury. And that 1.42 trillion translates to something like the carrying capacity of space of let's say, our solar system, not being 1 million. That was just a number I kind of put out there to make a point. Okay. So the carrying capacity of our solar system, remember the carrying capacity of Earth is maybe 8 billion. That's where we are right now. I can't really see the population of Earth increasing significantly beyond what it already is. So the carrying capacity of our solar system, based on the amount of mass that is needed to build these space habitations, is 50,000 trillion. Yes, you heard that right. 50,000 trillion humans can be provided lives of luxury by colonizing our solar system. know the details of this, the design of this space habitation, you should get the book.